I assume nobody is new to the area formula for a triangle, right? 1/2 base times height, okay, or base times height divided by 2, and it doesn't really matter how you think of it. Okay, where your base and your height are simply corresponding values. Okay, because in any given triangle, any side can be your base. Okay, so if we call this our base, I'm going to label it base 1. So if AB is our base 1, then the corresponding height is going to be this value h1. Okay, the perpendicular from the opposite vertex to that base is the corresponding height. But we could have called BC the base. If we had called BC the base, then the corresponding height would be this perpendicular, h2, okay, from the opposite vertex A. And again, we could have had AC be the base. We'll call that base 3 or B3. And if that's the case, then the perpendicular segment to the opposite vertex right here, H3, would be your corresponding height. Okay, so the only real thing to keep in mind is the base doesn't have to be the bottom side. Okay? It's not always on the bottom. It can be any of the sides as long as you have a perpendicular altitude or height to the opposite vertex. Okay? Then you have your corresponding height. Okay? So based on that, I want you to see if you can answer all 3 of these area questions. Okay? And then we'll go through them individually here in just a moment. But again, this is something that you should be able to do relatively quickly. The one on the left maybe has a slightly higher length of time for the calculation, but the other 2 should be really straightforward. All right, so I'm going to start talking through these, starting with this question right here, the one on the left. Okay, so the whole design of this question is to reinforce that 18.4 is not the base of this triangle. And that's because you don't know what that corresponding height would be, right? You would need to know this measure as well in order to calculate that height, or in order to calculate that area. So when we take our area formula, 1/2 base times height, we find any side length that we have a corresponding altitude or a corresponding perpendicular segment to the opposite vertex. And so here what we would get is, I'll type it into, or as a calculation into my answer field, 1/2, my base is 17.1, the corresponding height to that is 13.6, and so that would be my answer. If I was doing the full calculation on this and round to at least the nearest hundredth, okay, I would get my answer here, 116.28, but again, you can enter your answers as calculations. That is fine. All right, let's kind of keep moving here in this counterclockwise direction. We'll look at this problem down below because, again, this is another straightforward type of problem. You see you have an area of a triangle, which is 1/2 base times height. And so what you need to do here, just count the base and the height. Okay, so when we count this out, what we see is our base is 1, 2, 3, 4 units. And our height is this perpendicular distance from the base to that opposite vertex, and we can just count that 1, 2, 3, 4, 5 units for the height, and that just becomes the pieces that we fill in. So 1/2, a base of 4, a height of 5. However, again, those are easy numbers to calculate. 1/2 of 4 is 2, 2 times 5 is 10, and so you get your overall answer to be 10. Now remember, area is measured in square units. We see that up here. It doesn't specifically say, so technically this is 10 square units. I have the U to represent just unspecified units being squared. Okay, so it is a 2-dimensional measurement. The units will be squared. Okay, the final question here shows it shows a figure and it gives you a base, but it doesn't give a corresponding height, but you know what the area is. And so we'll use the same area calculation, 1/2 base times height, but this time we're plugging in the unknown A value first. We have our given base of 6, and we have our unknown now is that 1-dimensional measure of the height. So if we take 1/2 of 6, which is 3, divide both sides by 3, and we get our H value to be 12/3, which is 4, that is the corresponding height for this problem.